Hello students, welcome back to this lecture series of M.Sc. Part 1 Physics, Mathematical Methods in Physics. Okay, in the last lecture we discussed about the Cauchy integral formula. In this lecture we are going to discuss Cauchy integral formula for the nth derivatives. Okay, so what is statement or the theorems statement of the theorems? So let f of z, that is analytical in the simple domain D. This is a domain D, simply connected domains here we consider. So this f of z is a simply connected domains and that is analytical in these domains, and also one point we consider, that is z naught inside the domain D. Okay, and one closed C closed loop or the closed simple closed loop we are considering inside the D, and this point z naught is also enclosed by the C and D. Okay, so if this f of z analytical and this z naught is enclosed by C closed loop curve, and then the f of z has derivative of all order in D which is are also analytical in D. If this f of z is analytical in a D, okay, so its derivative for the all derivative also analytical in this domain. Then expressions we can write like this: f n z naught is equal to n factorial by 2 pi at a closed C f of z z minus z naught whole power n plus 1 dz, n is equal to 1 and 2. And this for this C it is a anti-clockwise traverse, okay, directions. So this is a statement for the Cauchy integral formula for the nth derivatives. Now we are going to prove this things for the higher orders 1, 2, 3 like this. Okay, so let's now first I am considering mathematical inductions. We are going to prove these things by using the mathematical induction method. Okay, so by the mathematical induction methods we consider n is equal to 1 first. So these expressions for the f primes z naught is equal to 1 by 2 pi iota closed C f of z divided by z minus z naught whole square dz. Okay, this is equation number first I am considering for the n is equal to 1s. Okay, so now by definition of derivative, you know the definition of the derivative, that is f prime z naught is equal to, we can write limit del z naught approach to 0 f of z naught plus del z naught minus f of z naught divided by del z naught. Okay, this is the definition of the derivatives. So here we want this f of z naught plus del z naught. Okay, then we can put these things here, and then we can find this f double primes. So by using the Cauchy integral formula, Cauchy integral formula, f z naught is equal to 1 by 2 pi iota closed C f of z divided by z minus z naught dz. Okay, this expression for the f of z naught. So if I write for the f z naught plus del z naught, so this is like this: f z naught plus del z naught is equal to 1 by f z naught plus del z naught is equal to 1 by 2 pi iota close C this f of z divided by z minus z naught minus del z naught into dz. Okay, this is the expression for the f of z naught and the f of z naught plus del z naught. Okay, so just I replace this thing with this two expressions. So a prime z naught is equal to limit del z naught del approach to z naught, and f of z naught is equal to what? Is equal to 1 by 2 pi iota I. This 1 by 2 pi iota is taking commons, and then limit del z approach to 0 close integral over C into brackets, that is f of z divided by z minus z naught minus del z minus f of z z minus z mod into dz. Okay, so now if I take this f of z is common, this is 1 by 2 pi iota limit del z approach to 0 close C close over C, so close integral over C, so it is 1 by z minus z z naught minus del z naught minus 1 by z minus del z naught to f of z dz. Okay, so we just prove these things first. So it is 1 by 2 pi iota limit del z is approach limit del z approach to 0 and close integral over C, so it is equal to z minus z naught. I think here is divide del z naught is by the definitions. Okay, so here is a divide del z naught by the definition, so I forgot here 1 by 2 pi iota del z naught. Okay, by the definition of the limits, so 2 pi iota del z naught. Here is also 2 pi iota del z naught. Okay, by the definition of the limits, so z minus z naught minus del z naught divided by z minus z naught into z minus z naught del z naught. Okay, this things is minus is here, so minus plus and this minus become a plus, so this thing is cancelled, here is plus. Okay, minus minus plus, so remaining is only the del z naught and this del z naught by the definition of the derivatives. Okay, so this del z naught will be cancelled and this is also cancelled. Okay, so now expressions for this f primes, that is f 1 by 2 pi iota close C f of z divided by, this is f of z, okay, and divided by z minus z naught into z minus z naught into dz. Okay, so just I am consider this denominators. Okay, so for this denominator I write the expression like this from this 1 is equal to 1 by z minus z naught, z minus z naught minus del z naught is equal to, if I take out this z minus z naught, is a common. Okay, so this is equal to 1 by z minus z naught whole square into z minus z naught minus del z naught plus del z naught. Just for the simplicity I am write this minus del z naught plus del z naught. Okay, and divide by these things, that is z minus z naught del z naught. Okay, now this we can cancel, z minus z naught and z minus z naughts. Okay, for these things only. So it is okay for these things. So we can write this expression like this: 1 divided by z minus z naught whole square into 1 plus, this is 1. Okay, if we cancel, and the plus del z naught, z minus z naught del z naught. Okay, like this. So here is the two terms, one that is z minus z naught minus del z naught divided by z minus z naught minus del z naught, and the plus del z naught divided by z minus z naught minus del z naught. Okay, so here we get the two terms. So this if I write, okay, so it is equal to 1 by z minus z naught whole square plus del z naught divided by z minus z naught whole square into z minus z naught del z naught. Okay, this is the expression for only this denominators. Okay, if I now replace these things with the limit is here, there is a limit, so okay, like this: 1 by 2 pi iota limit del z naught is approach to 0 close integral over c into, now I am read these expressions, okay, from these equations. So this f of z divided by these things, z minus z naught whole square plus del z naught f of z divided by z minus z naught whole square, z minus z naught del z naught into d. Okay, so this is expression for the f prime z naught. Okay, okay, so now by using MLA inequality theorems or method, we can change these things. Okay, so okay, so here in the MLA inequality, so if this distance z minus z naught, this is a very small distance, z minus z naught it is a very small distance. Okay, z minus z naught d, this z, that is a point, any point on the curve. Okay, so these relations we can write for these things, z minus z naught. Okay, so if I write like this, z minus z naught minus del z naught, so it is d minus del z naught. Okay, so it is equal then greater than or equal to z minus z naught minus del z naught, that is greater than or equal to d minus del z naught. Okay, so if I write for the inverse z minus 1 by z minus z naught del z naught, so it is less than 1 by d mod z naught. Okay, this is the expressions when this z is on curve and this f of z is analytical. Okay, so these things we can write, and this L, here we consider this L is the length of curve. Okay, so if I apply this here for this expression, so we can write so f prime z naught is equal to 1 by 2 pi eta close C f of z divided by z minus z naught whole square dz. Okay, and plus 1 by 2 pi eta limit del z approach to 0, limit del z naught is approach to 0, so it is close integral over C f of z to del z naught z minus z naught whole square z minus z naught minus del z naught into dz. Okay, so this is del z naughts. Now if this z minus z naught is very small, so for these expressions we can write 1 by 2 pi eta close C f of z minus z naught whole square dz plus 1 by, okay, this z naught or if I write in the mode, so this is become d square into d minus del z, and this when this del z naught approach to 0, so what happens, this f of z is also approach to 0. Okay, so from this we can directly write this f of z, these things is equal to 0. Okay, when this del z naught approach to 0 when applying the limits. So for that just I am write mode close C del z naught f of z divided by z minus z naught whole square and these things. I am directly right here mode, this is okay, so this is equal to plus MLA, this ML from the MLA inequality, see L for the length and f of z mode, that is less than m. Okay, for from this integral, so I am directly right here is the limit. Okay, so this is MLA mode is MLA or del z naught divided by this L for the length, and this is from the MLA inequality. Okay, so this z minus this is d square and 2 pi d square, and this thing is d minus mod z naught. Okay, so this is expressions for this second terms. Okay, ML, this L is what, length for curve. Okay, and this f of z mod is less than n. Okay, when f of z is analytical and z node is on the curve. Okay, so then we can write these things. Okay, so here if this del z naught when approach to 0, this thing is a 0, this f of z is equal to 0. Okay, so we get the expressions from here, that is f prime z naught is equal to 1 by 2 pi eta close c f of z divided by z minus z naught whole bracket square dz. Okay, this is result for the first derivative of the f of z's. Now if we follow the same procedures and find and replace this f of z with the f prime z naught, then we get the f double primes, result for the f double primes. So that is equal to see, if we follow the same procedure and we replace this f of z with the f prime z naught, and this f prime z naught is analytical, then we can find the second order derivative of the f of z, that is f double prime z naught is equal to 2 factorial 2 pi eta close c f of z z minus z naught cube dz. Okay. Similarly, we can write for the f triple third order derivative of the f of z. So that is equal to 3 factors 2 pi eta close c f of z divided by z minus z naught power 4. Okay, so like this, if we follow the same procedures, we can write expression for the f power n of z naught is equal to n factorial divided by 2 pi eta close c f of z divided by z minus z naught bracket power n plus 1 dz. Okay, so this f prime, f double primes, f this third order of the f, that is, and this f power n, this all functions that is analytical in the domain D. If this f of z is analytical, f of z naught is analytical. Okay, if this function is analytical, then is all order of this derivative of f of z naught, that is analytical. Okay, so this is general expressions for this Cauchy integral formula for the nth derivatives. Okay, so okay, let's stop here.